Well, hello, IM1 students. This is Mr. Reeves with you, and we are on lesson 9.4, normal distributions. And I thought I would work through several of the problems with you, since this is a little bit more of a challenging lesson. And hopefully you've had time to watch some of the videos and do some preparation ahead of time, so this will make a little more sense to you. All right, so I'm going to start with question number 1. It says the scores on a test given to all juniors in a school district are normally distributed with a mean of 72 and a standard deviation of 6. Find the percent of juniors whose score is no more than 78. All right, so real quick, let's make sure we're clear on what the meaning of this word no more than. So no more than would mean it can't be more than 78, but it could be 78. So we want to be less than or equal to 78. All right, so a mean of 72 and a standard deviation of 6. All right, so I made a copy of these normal distributions here. And just a reminder, on the normal distribution, right in the middle, that symbol right there is the mean. And also the mean and the median are the same on a normal distribution, but this is for the mean. And then if we go one distribution to the right or one distribution to the left, that covers 68% and so on. Again, you should have gone through this already. Just a quick reminder there. So they told us that we had a mean of 72, I believe. Now I'm doubting myself. Let's go back real quick and check. A mean of 72 and a standard deviation of 6. So if I were to go here on this one, we have a mean of 72 and a standard deviation of 6. You know what? I'm going to go ahead and use a different color. So we have 72 as our mean. And then we have a standard deviation of 6. So right here we would have 78, right? And that's the score that they gave us. They want it to be less than or equal to 78. Less than or equal to 78, right? So 78, again, would be one standard deviation over. So if you think about what we have here, we're going to have this entire side, right? And that percent right there is exactly half, right? So that percent right there is going to be 50%. I'm going to spend much more time coloring than this is worth. So this is 50% right there, right? Okay. And then, but we also need to include this part right here. Right? So we're going to add on this. Well, what percentage is that part? That part is 34%. So what percentage do we end up with? We end up with 50% plus 34% for a total of 84%. Does that make sense? 84% of our data is in between 84%. There it is. That's no better than it was. 84% is less than or equal to 78. All right, so if we go back here and I type in 84, I'm hoping it's going to tell us that we are correct. Oh, it doesn't tell us if we're correct or not. Huh. All right, here we go. The scores on a test given to all juniors are normally distributed with a mean of 74 and a standard deviation of 6. Find the percent of juniors who are between 68 and 74. All right, so this time we have a mean of 74 and a standard deviation of 6. So if I go back here, this time our mean is 74 and our standard deviation is 6. So here we would be at 80, right? and then we'd be at 86, and then we'd be at 92. If we went the other way, we're at 68, right? And then we're at 62, and then we're at 56, right? So what did they ask us for? They want us to be between 68 and 74. All right, so between 68 and 74 is right here, right? So here we are. What percentage is right there? Well, ladies and gentlemen, that is 34%, right? 34% is what we're looking for. Okay, so we can go back here. We're going to put in our 34%, and then we're going to go on to the next problem. All right, here we go. The scores on a test given to all juniors, this is starting to sound familiar, are normally distributed with a mean of 70 and a standard deviation of 7. Find the percent of juniors whose score is at least 70. At least 70. Well, this is going to be pretty darn not challenging, because if the mean is 70, 70 is right in the middle. It doesn't matter what the standard deviation is, right? At least 70 means greater than or equal to 70, right? And so what percent of the scores are going to be greater than or equal to 70? It's going to be over here, right? And that, ladies and gentlemen, as we know from the first problem that we did, is 50%, right? So that total is 50%. Anything to the right is 50%. Anything to the left is 50%. All right, so we could go here and we could put in our 50%. All right. So actually, I'm just really curious here. I'm going to click on this view example and see what it tells us. It actually does tell us the answer, 50%, and allows us to try another. All right. So I think maybe if we went back to the previous ones, right? Check answer. Oh, check answer. Look at that, guys. You can actually check your answer. This is amazing. All right, correct. If I go back to the first one and I check my answer, yes, I'm on a roll. Okay, so I want to skip all the way up to number 17. I think it's 17. Is 17? Yes, 17 is the one that we are looking for. And actually, I'm going to go ahead and open Desmos Graphing Calculator to help us on this problem. I really wish they had more than one problem like this on the homework. I can assure you that I'm going to provide you with, another one. So even though this is the only one they had, I'm just letting you know you need to be able to do problems like this. All right? All right, so let's go ahead and take a look at this problem. So they give us this list. It says 10 customers at this grocery store were surveyed about how long they waited in line. Their wait times in minutes are shown. Drag and drop the correct numbers into the boxes to complete the statements. So we're going to take this data and we're going to make a list. All right, so let's see here. 18, 14, 9, 8, 6. So I'm going to call this D equals, and then I'm going to put the bracket, and we had 18, 14, 9, 8, and 6. That was the top of our list, right? 18, 14, 9, 8, and 6. Then we have 4, 3, 4, 2, 2. All right, 4, 3, 4, 2, whoops. That's a 2, Mr. Reeves. 2, 2. And then we're going to close it off. And there is, why do we have two brackets there? and there is our 10 element list. All right, so we have our list. Hopefully I got those numbers right. And it says, what is the mean of the data set? Now we could add these all up and we could divide by 10, or we can use our newly found knowledge of Desmos to know that it will do the mean for us. Mean of D is equal to 7. How cool is that? So the mean is equal to 7. So I'm going to go ahead and drag that up. All right. Okay, how many data points are below the mean and how many are above the mean? All right, so I'm going to go ahead now and I'm going to make a dot plot of D, right? And then I'm going to click on it. Okay, so here we go. So our mean is 7 here, right? So this is our mean. In fact, I'm gonna go ahead and add an equation, and I'm gonna put x equals the mean of D, and it's gonna divide that for us, right? So there we go. So there is our mean, right? And if we look, we have 1, 2, 3, 4, 5, 6 points below the mean, and 1, 2, 3, 4 points above the mean. All right, so there are 6 points below. Oh, that's right, we're not typing it in, we're dragging it in. And there are 4 points above. Does the data appear to be normally distributed? Or does the data appear to be normally distributed? All right, the data has blank. It has, again, 6 values. No, it had 4 values greater than the mean, but 6 values less than the mean. So the distribution is not symmetric. So it does not appear to be normally distributed. And now I know that we can check our answer and we are correct. So kind of boring there. If I were to ask you, what does it appear to be? Does it appear to be skewed? It would appear to be skewed to the right, doesn't it? It looks like it goes down to the right. I'm just real curious. If it was skewed to the right, what does that mean about the median? Which side should it be on? What if we do the median of D? What happens? We get 5x equals the median of D, and that would confirm that it is skewed to the right, right? Because these points pull the mean over, but the median is here. So it is not normally distributed. It is not symmetric. It is skewed to the right. All right, so hopefully that helps you out a little bit in doing these problems. Once you get going, it's really not too bad, actually. It helps maybe to have this. It does not help maybe. It absolutely helps to have this diagram here. This one is good as well. If, for example, if I wanted to see all the points that were below here, right, or below there, I could know those types of things. But I like this one here because it breaks it down into sections. All right, thanks for watching. Hope this helped. Bye.